Hey, in this video, I want to talk to you all about linear equations. Now, the idea with linear equations is we want to have something what we call normally in slope-intercept form. So we want to have it in slope-intercept form. Now, you may be asking yourself, what is slope-intercept form? Well, slope-intercept form turns out to be y is equal to mx plus b. This is a function of a linear representation. Most people have heard of it in that form, it being linear. So another name for this would be linear. So the idea behind slope-intercept form is that, well, it comes from what it's written in its name. It has a slope and an intercept. Now, you may be asking yourself, well, what is a slope? Well, a slope itself is just a exchanging of x's and y's. Now, I don't want to get into like the whole backstory behind it, but think of it as any fraction or rate of change is what they would say. Most people have seen it as rise over run. Now, I can say any fraction is a rise over run. It just depends on what the context is that we're talking about this fraction. So, simple way of knowing is if you see a fraction or a whole number, that's what it also could be. Fraction or whole number, then that will at least let us signify that, hey, we're going to be looking at the slope. And it's always connected to the x itself. So you'll have 5 over 7 x, 5x, 1/7 x, or even x over 7. Now these two are really the same thing, but just written differently in different formats. So just be cautious on that. Now, the so the intercept portion is where it actually crosses the y-axis. So in this case, it's intercepting with an axis. It's crossing through an axis. Somewhere on this road or somewhere on this line, we're touching the y line. So that's what the y-intercept is. We're crossing through the y-axis. Now the usual representation is b. But just to let you know, as of right now, b is written as a coordinate point in the general senses. But for us to understand it, we just usually write the number, the back number, or the y, because that's how it would be written, x, y. So it would always be 0, something. But we're always going to use that something as the representation as when it's crossing. So we're going to go ahead and look at some examples, and we can go ahead and see how to construct a function or how to get it. Oh, and before I jump into that, actually, there's a way that I go ahead and phrase it, or there's a way that I want to say it like this. So what I talk about when I'm telling students or when I'm talking to other peers about how I work with slope-intercept, I always tell them like this. If you listen to Drake, you're going to understand the reference. So if we start at the bottom, now we're going to go to there, or start from the bottom, now we're here. So we want to end up from the bottom and end up here at the top of my pyramid. So usually this is like the pyramid that I talk about when I'm talking about linear equations or anything. I'm going to write some names of some formulas, and we'll talk about it later on. But for the most part, everybody just usually starts off with the y is equal to mx plus b. This is usually the most important formula, so that's where they'll start from. So the beginning or the bottom of our pyramid, it always slopes. You always have to have slope or rate of change or a fraction, or you always have to have this changes of y's and changes of x in order to claim that it's a slope. So we have to have slope. The next piece to this is what we'll call point slope. At this point, you have a point, you have a slope, and now we're trying to create a formula. Now these equations are like essentially a scaffold. They build on top of one another. So unless I have slope, I can't use point slope. Unless I have a point and a slope, I can't use point slope or slope intercept. And that would be the next one in our cases, slope intercept. So then now the last one that we'll go ahead and talk about right now is standard form. Standard form is like the least used version, but it's still there. You still got to know about it. You got to think about it such as like using like just simple things overall. You want to make sure that you just have the ability to do this, because this is going to be like the prettiest version that you can get it into. Most problems don't ask you to get into standard form because we like everything to be in the y is equal to, so that that's what we work with normally. But some problems may give it to you in standard form, and you have to work backwards from there. But I digress. So we're going to go ahead and maybe look at a problem or two, depending on the time that I have still, and we can see what we're going to talk about. Alright, so I got this word problem here. So a candy company has a machine that produces candy canes. The number of canes the candy canes produce depends on the amount of time the machine has been operating. The machine produces 294 candy canes in 6 minutes. In 13 minutes, the machine can produce 637 candy canes. Okay, so you may be asking yourself, what am I supposed to get from here? I don't see anything. I don't understand what the problem may be asking. Well, we got to understand what the machine is doing. So then what I like to do is maybe you can draw yourself something that may help you. So here's my machine. Looks like one of those little Mario poles. Boop. All right, so if I'm trying to make something out, so I'm trying to make this candy cane. So I'm going to drop something in here, some ingredients. It's going to pop out, and then I have my little candy cane. Candy cane. Awesome. So we drop and we get our candy cane. But, so the way it looks like is that the number of candy canes produced depends on the amount of time the machine has been operating. The machine produces 294 candy canes in 6 minutes. So what that's telling us is that every 6 minutes, we can get 294 candy canes. So we got to think about it. And I'm putting 6 minutes first because you got to think about it in terms of X's and Y's. What's happening? What's the exchange for one another? What is the dependent on the other one? Which one depends on each one? So does the minutes depend on how much something is produced, or does producing this amount depend on 6 minutes? So you got to think about it as which is being affected more. Well, if I work 6 minutes, then I can get out 294 candy canes. Or if I leave the machine running for 6 minutes, I can get 294. So this is the idea, is that I'm going to have minutes as my X and the production as my Y. Because I want to say that if I leave the machine, because it leaves me with more information and it tells me like, oh, I got 6 minutes on the machine, I can produce 294 candy canes. So if I'm at 6 minutes, I can get this many candy canes. So that's kind of the way we're going to structure our idea behind this problem. So what I will say is we have 6,294 as one coordinate point. So this itself is 1 point. Then we will say, oh, we have another one that tells us 13 minutes produces 637 candy canes. So then now this is coordinate point 2. So then at this point, we can go ahead and find slope. You may be asking why? Well, this is a x1, y1, x2, y2. So all it's telling me is that this is my exchange in y's. This is my change in y's and my change in x. This is what the rise or run is going to look like. So what we can say is using the formula that we have. So the formula for slope, it looks like this. In other videos, I'll go through it a little bit slower, but this turned out to be a word problem, so we'll work based off of that. So we're going to say 637 minus 294 over 13 minus 6. Now, I'm not good at mental math, as you noticed before in my other videos. I'll be straight up. That's something I got to work on. Maybe one of y'all got some tips to leave me. Go ahead and leave it in the boxes in the comments so that I can go ahead and see what I can do to become better. So then we see this, that our changes in slope turn out to be 49. So then what that tells us is that our slope over R is 49. So in the beginning of my formula, I can write y is equal to 49x plus b. Now, I'm gonna use one way of doing this. Later on in these videos, I'll show you other ways of kind of like working out these formulas depending on what they give you. But in this case, I'm just gonna go ahead and try to do as quickly as I can. So they give us, I already have this formula. So this is kind of like step 1 of what I want to do. Step 2 now is to go ahead and plug in my x's and y, or an x and y, into the equation. So what I'm going to say is I'm just going to grab the first point. No specific reason why, I just do. that one, it just make, like, I'm not going to confuse myself more. So I'm going to say 294 is equal to 49 times 6 plus b. So I'm plugging that in. So you could have used the other point. The second point is just don't confuse yourself. Just grab the first stuff. So 49 times 6, 294 is equal to 294 plus b. Subtract 294, subtract 294. Boop, boop, boop. So then we get 0 is equal to b. So then what we could see now is that our equation turns out to actually just be y is equal to 49x. So in later videos, we'll go ahead and see like how to answer these questions out more thoroughly. So stay tuned to continue watching these videos. Thanks a lot.